Well, hello, friends. I was I had shared last week, I think, um, a video and a post about using a loop and ladder distribution piping design with subloops. And I got asked some questions about that, and they said, and so decided to do a little follow up video with a real example um, from an imaginary plant. Just kidding. So this is the Google Earth view of a facility, and here are the compressed air drops, the process points. These blue circles represent where they use compressed air, and their compressor station is outside right here. Um, so, in this case, if we were going to uh, design a piping system for it, we have multiple options, right? So the first one would be a straight header design. And if we did a straight header, we'd find a place to come across this way, we'd find a place to come across this way, and then we would connect the processes to it. Now, in this case, we know that we would have to oversize that tremendously if we wanted a chance at all of not having pressure issues because we're robbing the airflow from the distal processes uh, from the near ones. So some people might say, well, then let's consider doing a loop design. Well, if we're going to do a loop design, then we would find a position going around the facility, and this would give us 2 points of contact to each process, and then we would tie in the individual processes from there. This oversimplifying, I guess, would theoretically cut the pressure drop in half based on a couple things that we really just don't know, nor have we stated in this case. So, the next style you would see is what we call a loop and ladder or a loop with cross headers. And here we'd see that we connect cross headers across the facility and then tie in the process points to those crossheaders. Now, we start to see a little bit of benefit here because if you put isolation valves in on both sides of these crossheaders, you can isolate that and do work on that main header. Sorry, that crossheader. Whereas in the whole loop, shutting an isolation valve doesn't do anything except make a really big single header design. Now, these are some of the options that we talk about on a regular basis, but if we know how to do process mapping, right, evaluate each one of the processes individually, you look for process groups and process outliers, right, and we determine which process air connections operate similar and which vary from each other. Then we get a little different situation because now we can see that there are very distinct process groups in this facility. Now, when we talk about process mapping, it's not just pressure. Um, Heck, it's not just pressure, temperature, volume, and quality. It's also utilization, cycle. You want to know if there's intermittent demand. You want to know how many hours a day is this? Do these processes need air? Right, all of these things take into account. You're looking for everything that makes them similar and also everything that makes them different. And then this allows you to group them by geographical area, by pressure, by all the different factors that we've already stated, and determine, hey, what makes sense for these. Now, I want you to consider for a second a system where the compressor station ends in a dry receiver tank and then goes into the distribution. But for a second, please consider that instead of the dry receiver being a piece of the compressor station, consider the receiver tank a piece of the distribution loop. Because what we can do here is we can first modify the loop so that uh, our area is covered. I know you see that first circle up there on the top, and that is definitely an outlier. That is a random use. It definitely has to be there, but they almost never use it. In fact, I think we connected a 25 millimeter line with an isolation valve, and there's a regulator um, running that line. But what this design enables you to do is now you can create subloops that will handle that process group individually. Now, when you let's go back to this receiver tank, right? When the system, in fact, we'll go back all the way. In this case, right? In this case and the other cases with the straight header, with the loops, and even with the loop and ladders, the demand profile is going to change all the way the length of its range, right? And your primary storage and your distribution piping are sized to account for all of that. But when we use this design, we can look at the cycle and the individual characteristics of that process group. And then we can use our process tools, whether it's pressure control, flow control, different levels of filtration and drying, um, boosters, isolated compressors, backup, storage, but we can provide this as its own mini compressed air system, right? One of the cool things that you can do is you can also determine by putting a flow meter and pressure transducer at the individual subloops. Now you can actually measure how that process group is utilizing compressed air, and you can hold that process group accountable um, all by itself, independently from the rest of the facility. So, a couple things here is you still need to make sure that you have good piping size going around the length of the facility. You also really need to have a good understanding not only of process mapping, but also boundaries, right? Because you start getting into pressure control scenarios here where, right, we talk about this regularly, right, where we talk about pressure set points on the compressor, pressure leaving the compressor station. We have pressure at the FRLs, right, at the processes. But remember also, we have zone pressures, and you see that here with the subloop design. Um, you see that you have a zone level pressure control. And then also don't forget that inside your process equipment, you also have pressure control inside the process equipment itself. But here's where we go back to the boundaries of our systems, right? Your customer is going to tell you where the boundary is for them, truth be told, right? They might say, oh, this machine is under warranty, or we're not allowed to go past this, or I want you to provide to X. And, this packaging machine requires this flow rate and this cycle, right? So when you're doing your process mapping, you might effectively be doing mapping of a process group, right? Depending on where the boundary is of your system. But depending on where your boundaries are, depending on how you group your processes, you can find a very cool tool is to create these small little subloops and tie those into the main loop. Now, I've said this a couple times, but I want to take a look here, right? Like, look at this piping, the main loop piping that goes around this building. Let's say that piping is 50 years old, right? And you evaluate the plant, and the piping is undersized, it's inadequate, blah blah blah, this and that, right? But a lot of times, when you look at the impact on production and the sheer size of the overall plant, it's a Herculean task that a lot of times the customers don't want to take into. Well, first of all, you can do it either way, right? You could run a new loop, right, first, or you could also run the sub loops. Pick a sub loop, pick the most critical or the biggest outlier to the facility, the zone that has the most differences from the rest of the plant, and now isolate that with its own sub loop first. It's a small amount of piping. You can make sure it's properly sized. It's leak free. It has permanent monitoring on it. It has all the filtration and drying and instrumentation that it could want and need, as well as storage. Um, and you can just move in pieces until you get the whole plant done. Um, so I hope this does a better job of explaining um, loops and sublooping. Um, I will tell you, especially if you use receiver tanks on these subloops, if you use receiver tanks to cover the cycle, um, you'll see that you'll get a lot less fluctuation at the compressor station um, to the overall system because that is eaten up by the individual subloops. And oh, by the way, one of the greatest ways to reduce your cost in a compressed air system is to isolate um, processes that don't need air when they're not being run. And when you use this design, it's a very easy way to shut one isolation valve, and now you've killed air to an entire section of a facility when it's not being run. In fact, this specific facility here, these three green dots, these three green dots had to run 24/7, but nothing else in the plant did. Everything else was Monday through Friday. I think it was about 4 a.m. to 9 at night, Monday through Friday. These three golds actually were less than that. That was like 4 hours on a Thursday or something. But when we looked at these three green dots, they had to run 24/7. So by using the loop and subloop design, we're able to isolate out everything else and reduce a whole lot of leaks and load on the compressed air system as well. So as always, I hope you guys stay safe out there. And if this didn't clear things up, give me a call, send me a message. I'm happy to help.